let me throw in the buzzword deep learning here, and all kind of the excitement around that, right? So Google open sourced their project now. Now you had what's the Tesla CEO, Elon Musk. Get together with a few others, doing an open source deep learning. Where's Microsoft, and maybe if where do you see the potential?
Yeah, so let me first address the potential, and then let me talk about Microsoft. So I think deep learning is one of those technologies that has really hugely benefited from two things. One is obviously the growth of compute capabilities, and second, just the sheer availability of data and our ability to process data at scale on reasonable timeframes.
Yeah.
Because a lot of the architectures in deep learning, of course, there's been a lot of innovations in the last 3 to 5 years. So that's.
But the principle is not new.
But the principles are not new, right? They've been around for like decades now.
Right.
What I think really broke through was our ability to take large amounts of data, because these models can become arbitrarily complex. They can construct lots of interesting topologies. But then the question becomes, okay, you have a billion parameters, you have a few billion parameters, how are you going to estimate them? Well, in order to estimate them, you really have to work with tons and tons and tons of data so that your estimates of these parameters are reliable, robust, and generalizable. So I think deep learning has really is really going through a golden period now, where the confluence of both availability of large computing resources as well as availability of large data, especially now with these internet companies having the ability to get tens of millions of images or tons of speech data, or tons of text data, etc., is really bringing all these things together. Now, where do I feel deep learning can really make a huge impact is what I really call as our perceptual experiences. Because despite all the advances we have around understanding numerical data, text data, etc., areas like computer vision, areas like speech recognition. For example, if there are 2 or 3 people talking there in a crowd, to be able to decipher and automatically quickly infer, okay, there are 3 speakers there, and these are what they are saying independently, etc., is still a very, very hard problem for a computer to do. So these sorts of perceptual experiences around, I think, computer vision, around speech, even around text processing, audio, speech and signal processing, etc., really where I feel deep learning is going to achieve a lot of benefits. And I think they have been, especially if you look at the last 2-3 years, the developments recently. So coming back to your second question, where Microsoft is doing this, we are actually have been investing in this very, very heavily. In fact, as a company, Microsoft has been doing deep learning and in areas like speech recognition for like more than a decade now, right? We have a very established, very, very reputed group in MSR, Microsoft Research, that's done some of the pioneering work around speech recognition. For example, now you can go to products like Skype and talk in one language and get it automatically translated to another language and have a conversation with somebody in like 2 different ends of the planet in different languages that are automatically translated to the other person's language. This is happening in real time.
Star Trek is coming true.
Star Trek is coming true, yes. So areas like, I think, computer vision, speech, and very recently, so we have also put out our technologies that we have developed for some of the frameworks we have developed for this, called the Deep Learning Toolkit. We have released some of the deep learning toolkits. In fact, just last week at the NIPS conference, we announced the availability of these things. And more importantly, what I'm personally very excited about this, because there is now there are these groups and large companies which are working on deep learning. The pace of innovations are growing exponentially.
Right.
So last week, for example, one of our Microsoft research groups in Asia got the state-of-the-art performance on a standard computer vision benchmark data set called the ImageNet. So it's a in that data set, we are now able to able to get accuracies, the top 5 accuracies, to within about 3.5% or so, which, if you think about it, is almost on that data set is almost approaching human levels of accuracy, right? So my guess is in all these perceptual experiences and these perceptual tasks, it's the human accuracy that is like one real milestone to cross. And in some of these areas, I think we are close to the threshold. Sometimes
we're getting there. Yeah,
we are almost getting there. Which if you think about it, is incredible because now, admittedly, it's still on narrow tasks. So the next frontier, I think, will probably be how generalizable are these things. For example, if you have learned on one data set about some concepts, how generalizable can you take it to other concepts? And that seems to be an area where deep learning is pretty powerful as well. I think people have in the last few years taken deep learning models trained on some problems and try to apply it on different problems within the same area like computer vision or speech, but they've tried to apply it on different areas, and it looks like they are generalizing to more than what people expected. So which is very, very exciting. So we are a very, very active research group in this. And now, for example, you can go to, Azure ML, Azure Machine Learning. And if you have deep learning models that you've trained in using any of the tools like Caffe or Torch or any of these tools, and actually take that deep learning model, put it as a web service, and really host it as an endpoint. So coming back, I think deep learning is a really fascinating area, and also, frankly, even with all the advances and progress that's happened in the last, I think, 5 years or so, I think we are still in the very early stages of deep learning. I think it will fundamentally change the way we interact with machines, with unfortunately even with each other. I think in like many ways, I don't need to be that pessimistic. I think in like many ways for the better, because being able to communicate with people in different languages, that's such a powerful capability, right? So just wanted to show this. This is one deep learning model, right? So what this is it's a deep neural network digit recognizer. It's trained on a really popular data set in the machine learning community called the MNIST data set. What is happening here is that we have trained a deep neural network model. Now it's hosted as a web service on the cloud.
Okay.
Right? So you can now go write any digit. For example, I'm going to say write 3 here, send it. What's happening here is that this neural network model, deep learning model, is available as a REST API hosted on the cloud.
And it
takes the image that you've just written here, calls that API. This is a very simple application. It just calls the API and now recognizes the digit.